In this demonstration, we are going to be using ultra-fast high gigabit network to link two sites between Madison, Wisconsin and Stillwater, Oklahoma. And the purpose is to demonstrate that after you do your virtual analysis using the virtual reality based environments, some of you may have seen the earlier video where we showed you that it's very difficult to assemble them directly, and you want to use the virtual environments to compare and contrast different assembly strategies. Once that is done, you can download the instructions and perform this automatically, or using the benefit of the ultra-fast network, you can remotely link distributed sites, and you can get feedback from the cameras to accomplish the complex microassembly activities. So just to jog your memory, microassembly is an emerging area, refers to the assembly of micron-sized devices. When we have complex shapes, complex geometries, and varying material properties, you can't use MEMS. You'll have to physically assemble them, and that's where our demonstration and our development comes in. We accomplished the physical tasks. Again, the equipment was at SICE, the Center for Information Centric Engineering in Stillwater, and at Wisconsin Madison, Mr. Aditya Prakash with Professor Ramanathan was able to control and assemble after they came up with a possible assembly plan. So I'm going to show you this recording. So before I go further, we have the screen. It's split into the top half is the top view of the microscopic camera, and this is all in the microns and the millimeter range. And the bottom half is a side view. We actually need 3 cameras, but we're just showing you 2 views, and this is necessary because you have to pick and place them accurately. Sometimes adhesive forces come into play, and having these cameras gives us an idea about what's going on, and so that if we have to intervene, we can do that. Plus we can also precisely pick and place them. The equipment that we are using is very expensive, so that's why we propose the candidate solution in the virtual environment. We have a pretty good idea there, we collaborate, we discuss, and then we come to the physical environment. So here you see a gold wire mesh, and in the bottom half, in the side view, you'll see there are 2 cams. There are a few millimeters end to end. Thickness probably between 10 to 20 microns. You can see there's a thin rod that is like a fixture which is holding these target cams. They're going to be picked from this area where there's a gold wire mesh in the background or at the bottom, and the gripper is going to rapidly pick and place it in a different destination. These are the wire mesh rectangular, roughly I would say 500 to 600 microns. Height wise of this mesh, or rather this individual mesh wire rectangle, probably between 100 to 150 microns. Here you can see the tips of the micro gripper. Now I'm going to continue with the assembly. You can see the pick and place, and here the gripper is clearly lifted, as it can be seen, has lifted the first target part, and then it's going to move. And I've just paused it, and I'm going to restart and run this. Then it's going to move, and this part we've edited, and you can see as we come to the end of the wire mesh, it's a little bit darker as it reaches to a different element of my target part. It's going to continue to move. It's moving over the destination. Here it's a blue block. It's coming on over there, and this is where control becomes important and the feedback is necessary. So we can use such an ultra-fast network not only to accomplish the actual physical activities, but we can also train this in an actual industrial environment on an engineering class, as we have shown over here. And here is the target destination, and here again is a pin, and I'm going to start the recording. It's moving over the pin. I'm going to pause over here. As you can see, we've been able to move back and forth, and now it's going to drop the target cam over the pin. It's going to move. It's going to fall through in a very precise manner, and it's moving really fast. Again, I edited a part of this video, and it's gone back to the mesh area to pick up the second pin. It's moving over here, and I'm going to pause it. It's moved really fast because I edited it, and it's come over the almost near the target destination, which is indicated by the wire or the pin. And here you can see the cam almost near its destination. It's going to move in, and it's almost gone halfway through when I paused it. And we continue, and it's going to go towards its final destination. Now it's going to start I'm going to start the second demonstration. This is a little bit more advanced, and here you can see a cam. You cannot see the wedges. This is again a few millimeters, but it's in an electronic circuit context. You can see a chip over here, and this is going to be picking up this cam and placing it at a different location, and you can see the side view at the bottom half of the screen. I'm going to let this run as I give a quick commentary. It's going to move. It's cleared the pin. Now it's moving again. You can see the side view. It's moving, and we've adjusted the side view camera. So it's gone over the target destination. As you can see, the contrast is very clear because of the black circuit board background. Again, this is a very advanced manufacturing or electro manufacturing example. And I'm going to run. It's going to move. I'm going to quickly stop over here because my target destination was this pin over here. So it's a gold pin. It's roughly about 1 millimeter in diameter, and I'm going to drop this pin over here. It's going to slide through, as you can see over here.